Alright, so now that we've got a little bit of the theory regarding flat rate depreciation, let's take a look at how some of the formulas can help us to solve problems. So again, the focus of this chapter is about thinking about finance in terms of a recursive relationship, so with recurrence relations. Okay, so here's our formula that we've got for the recurrence relation. Okay. So we've got that Vn is equal to Vn minus 1 minus D. Okay, this is where D represents the yearly depreciation. So this is the amount, not percent, the amount that's being subtracted each year. So I can figure that out using our good old percentage concepts. That's going to be the original amount times a percent if we're given a percentage as part of our answer. Okay, so I want to be able to figure out the future value in terms of the previous value by subtracting whatever my yearly depreciation is. So let's look at an example where we want to set up this type of relationship. So a car is purchased for $18,000 and depreciates at a flat rate of 15% per year. Okay, so I wasn't nice enough here to just say it loses blah dollars per year. Okay, I'm going to make you do a little bit of work to figure out actually how much money it's losing each year. So I've been asked to set up a recurrence relation. So basically that means I need to fill in what D is. Okay, what is my yearly depreciation? Okay, so if I'm losing 15% per year of $18,000, well, D is equal to 18,000 times 15 over 100. Okay. I don't expect you to be able to do that in your head. So you get out your calculator. 18,000 times 15 over 100 is equal to $2,700. Okay, so that's the amount we're losing each year. So each year we go down by $2,700 of our previous balance. Okay, so let's put that in. So my yearly depreciation is $2,700, so I need to put that into an equation. So to get my current book value, I take my previous book value and I subtract off 2,700. And as always, with the recurrence relation, I should state where I start. In this case, 18,000. Okay, so that right there, that's my recurrence relation. So it tells me how to get to the next term. Well, I subtract 2,700 and where to start. So let's use that. So the second part asked me to create a table. These can also be called schedules, which shows the book value for the first 5 years. Okay, so I always like to fill in the 0th year. Okay, so $18,000, and then this is where you have to ask yourself, well, if I'm currently sitting at 18,000, how do I get to the next year? Well, my recurrence relation says I subtract $2,700. So I subtract 2,700. That's going to show you a little bit of a hint on the CAS here. So if I do 18,000 minus 2,700, I press enter. Okay, I get my answers $15.3 thousand. So I go back here and get 15.3, $15,300. And again, to go to the next value, I would do the same thing, subtract another 2,700. But I just want to show you a little bit of a trick that you can use on the CAS so you don't have to type minus 2,700 each time. Here, instead of typing 15,300, I'm just going to press minus. Okay, it says, do you want to take your answer from the previous line and subtract, or do you want to negate? I'm going to click, I would like to take my answer and subtract 2,700. Now this answer here is just pulling whatever was on the previous line. So now when I press enter, I get 2,600. Now if I press enter again, it's just going to keep doing that concept of taking whatever was on the previous line and subtracting 2700. So it's almost like built-in recursion with the CAS. Okay, so I've got all my values here, and notice all I had to do was press enter. You don't have to type the minus 2700 each time once you do it once with answer. Okay, so I get 15, 3, 12, 6, 9, 9, 7, 2, and 45. So let's put those in. So 15, 3, 12, 6, 9, 9, 7, 2, and $45. $100. So this shows a lovely setup of that schedule. So it starts out at 18,000, drops by the 2,700 each year. So after 5 years, it's worth 4,500. Okay. I didn't mention anything about scrap value or anything like that, but let's just have a quick look about what this graph would look like. It's a little bit of a cooking show magic moment here. So here I've got N and Vn, as I've got for that set of data, that relationship. If I was to plot that graph doing N versus Vn, again, we'll notice linear graph, so that's a nice line there. And each time I'm going down by 2,700. Okay. If I'd continued this relationship, at some point it would go below 0. At that point, the equation kind of loses its relevancy. So if I went down 2 more, I'd get to the negatives and I'd be beyond where it's getting written off. That's a bit of a funny thing that can happen when we do flat rate depreciation, because I'm always subtracting a number. I can actually get below 0. Okay, so that's the idea of using recursion.